Welcome to topic 2.1. In this topic, you will learn about the different kind of air conditioning systems that exist in a building, okay, as well as the most common type of cooling system, that is the chilled water system. So basically, there are two types of aircon system. Okay, we can classify them as direct expansion, in short DX system, or a chilled water system. So what is the difference between these two? For a DX system, okay, you get the cold air, because for air conditioning system, our purpose is to get cold air, okay, cold air. So the air that is being cooled down, the heat must be removed by some cooling agent, okay. So for a DX system, the cooling agent is actually the refrigerant, okay. The refrigerant is the one that will remove heat from the air. And of course, the most common type of DX system can be found at home, okay. All the domestic kind of air conditioning system is actually DX system. The second type of cooling system or aircon system we have is called chilled water system. Chilled water system. So what is the difference between these two? So for chilled water system, your cold air is being achieved not by refrigerant. Instead, you get your cold air because of the cold water, or we call it chilled water, that flow around the building. So the cooling agent in this case is the chilled water. And of course, how does the water get cooled down? That is by the refrigerant. So you can see that there's an additional loop. If you look at the schematic, there's an additional loop, okay, and that loop is called the water loop. Later we will look into details of these two types of air conditioning system. So let's focus on DX system first, direct expansion. So direct expansion system, as I mentioned just now, you achieve cooling by having a cold refrigerant to cool down the warm air. So typically you can find this at home or in small offices, or for those maybe your FCC rooms and things like that. And the condenser, okay, which usually we call it the condensing unit, is usually being cooled down by air. So you will realize hot air always come out from the condensing unit. So what is the advantage of having this DX system? The main advantage, of course, is very simple setup. You have your four components of the vapor compression cycle, and that's it. Okay, and the main disadvantage is because if, let's say, there's a refrigerant leakage, because the problem is you have to transport your refrigerant to the place you want to cool down, and that may be some distance away. So let's say it's like 15 meters away, and throughout these 15 meters, if there's a leakage, it's very, very hard to detect, because the refrigerant will leak out as vapor. Okay, there's no color, there's no smell. It's very hard to detect the leakage. So for DX system, there are three main types. There are three main types of DX system, and we classify them as unitary, single split, and multi-split. So in a DX system, there are two loops. There are two loops that exist. First is the vapor compression loop. As you can see, there is your condenser, your evaporator, your compressor that you have learned in topic 1. That is what we call the refrigerant loop. So your evaporator, which is the cold side, okay, and the low temperature side, will be used to cool down your space, okay, the air. So what you have is cold refrigerant going in, okay, passing through a cooling coil, and finally leave the room. So this part here is the evaporator. And what we have over here is a fan. Just a recap from the previous topic. Okay, we have a fan that is blowing across your cooling coil, and you achieve cold air after passing through the cooling coil. So it's a very, very simple setup. Okay, and the temperature that you are going to encounter is roughly around this range. the refrigerant that go in may be around 10 degrees Celsius. Okay, of course that depends on the set point that you put in your room. Okay, so let's say a refrigerant going as 10 degrees Celsius, it may leave the room at around 17 degrees Celsius, 16 or 17 degrees Celsius, and after that is being transported to the compressor, and the whole cycle will repeat in the vapor compression cycle. And at the condenser side, the hot refrigerant may be around 50 degrees Celsius, and you use the outdoor air, the ambience air, to cool it down. And these are the two areas where heat exchange actually take place. So just now I mentioned there are three types. Okay, first you have unitary system. So what is this system about? Okay, unitary system is the most so-called old school. Okay, it used to be very common. Okay, but nowadays you seldom see it anymore. Okay, last time we used to call it a window unit. So in very old flats, you may notice that there are still this kind of air conditioning system where the whole unit is mounted at the wall. Okay, whole unit is mounted at the wall where the inlet face the room, and the so-called outlet, the hot region, is being stick outside the room. So cold air will be blown inside the room. So let's say you have a room and the window unit is over here. So cold air will be blowing this into the room, whereas your hot air will be rejected outside the window. So that's what we call a window unit. And nowadays you seldom see this in anymore, or in the new apartment. Okay, so where we can put this is maybe in site office, your construction sites, because usually all these site office, they are temporary. Maybe you need to install for 1 year or 2 years, or then after 2 years you can actually remove the window unit and use it for another temporary site. So it makes more sense because it's more so-called portable. You can actually shift it around. So, but as for home kind of aircon, which is more permanent, we seldom use this anymore. So another type, okay, the second type of cooling system we have at home or for DX system is called a single split. Single split. So this is much more common, and you may have one of these at home. So why is there a word split over here? And what does this split actually represent? Okay, why is it the word split? It means, for example, let's look at the vapor compression cycle again. Okay, you have a compressor, your condenser, your evaporator, as well as your expansion valve. Okay, as well as your expansion valve. So the evaporator, which is the cold side, okay, is being split from the rest. So you imagine these three components are housed inside a box, which is called a condensing unit. Okay, so these three components are housed inside this condensing unit, whereas this evaporator is located at the place where you want to cool down, which is your FCU, okay, your fan coil unit. So fan coil unit effectively is a fan, okay, that is blowing across the cooling coil. Okay, that's why it's called a fan coil unit. So when the evaporator is being split from the rest of the components, we call it a single split system. So typically, this length over here, it cannot be too long. Okay, it's not possible for you to have a condensing unit at maybe level 1 and an evaporator at level 5, okay, or level 10. That will be your refrigerant will have to move through a very long distance. So usually, the distance between your FCU and your condensing unit should be kept at around 24 meters. And of course, the nearer it is to the condensing unit, the better it is. And the last one, okay, that you have, which is a DX system, that is your multi-split system. So single split and multi-split, What is the main difference? Of course, multi-split refers to if you have a multiple FCU. Okay, if you have a multiple FCU, then it's called a multi-split. So for example, you may have only one condensing unit, but you may have more than one FCU. So it's common in, let's say you have a 4-room. So you have 3 bedrooms with 3 FCU. That is called a system 3 air conditioning system, which is also called a multi-split system. Okay, so if you have more than one FCU, it's called multi-split system. And nowadays, it's very common to see this term, which is called the inverter. So what does this inverter actually refers to? If you understand what is a VSD, okay, variable speed drive, is like a variable speed drive for your compressor. Okay, so traditionally, an air conditioning system, how do we control the temperature? So, for example, in the past, let's say when you just switch on your aircon, okay, and your room is around 30 degrees Celsius, what will happen? Temperature will start to decrease. Temperature will start to decrease. So let's say you set a set point at 24 degrees Celsius, your temperature will start to slowly reduce towards the set point. But of course, it will not stop at 24. Okay, so once maybe there's a band of 1 degree Celsius, so your compressor will continue to run. Your compressor will continue to cut in and run until it hit the lower bound, which is 23 degrees Celsius. So when it touches the lower bound, what happens is your compressor will cut out. That is when your compressor is not moving anymore, only the fan at the FCU side is in operation. So what will happen is your temperature will start to slowly increase again. And the upper bound maybe is 1 degree higher than a set point. So when it touches the upper bound, your compressor will cut in. So this cycle will repeat by itself. Okay, so traditionally that's how we control the temperature of the inside a room, by cut in and cut out of the. So this part is where you cut in, this part is where your compressor cut out. Cut in and cut out your compressor. So that's why you may notice in the olden days, okay, when you have this unit, you may realize that suddenly the condensing unit will make a loud noise. It will make a loud noise, then after a while it will stop. That is because your compressor is cutting in and cutting out. So nowadays you may not notice this anymore, is because the speed of the compressor, they are able to modulate it. You don't have to be either on or off. You can on at a certain percentage. So it's like a VSD, it's like a variable speed drive for your compressor. So the control of the temperature will be even more accurate. Okay, it will hover around 24 degrees Celsius, and you will not have any wastage of energy. Okay, because this one that you will have to cool it down until 23, then let it slowly increase again. So there may be some wastage of energy. So nowadays, inverter system is much more common because it's very energy efficient. So here are some of the kind of different FCUs that you may have seen. Okay, either in office or at home. So you have your ceiling suspended FCU, the different kind of cassette FCUs. So first question, okay, first example we have is a multi-split system, right? Okay, usually have 3 or 4 FCU. And inside the box, okay, although just now I mentioned you have a box, a condensing unit, it doesn't mean that inside this box, right, there's only one compressor. You can have more than one compressor. So sometimes there may be more than one compressor inside. You may have up to 2 compressors. So why is that so? For a multi-split system, why do we want to have more than one compressor inside the condensing unit? Okay. So, of course, the main reason is because, let's say you have only one compressor and you are operating at part load. Let's say you are only operating in 1 bedroom. Okay, the rest of the bedroom, you are not switching on your air conditioning system. Your living room, you are not switching on your aircon system. So that is what we call a part load. You may only need 25% of the capacity of your condensing unit, of the total capacity. So if you only have one compressor, it's running at maybe 25%. Okay, you only need 25%. But let's say you have two smaller compressors. If you have two smaller compressors, you can afford to run one compressor at near to full load, okay, near to full load, and the other one you totally don't switch it on. So it makes much more sense to have multiple compressors with a smaller capacity housed inside this condensing unit, rather than one big compressor to handle all the loads, because usually you don't switch on all the aircon at the same time. So that's the reason.